Today's lesson describes how to write half reactions. There are two different types of cases for writing half reactions, just as there were in balancing redox reactions with oxidation numbers. We will examine how to write half reaction equations in acids and then in bases. The first step involved is writing the chemical formulas for the reactants and products. At this step, we don't expect the equation to be balanced. We're just figuring out what the reactants and products are. In step 2, all of the atoms, with the exception of oxygen and hydrogen, are balanced. In step 3, we balance the oxygens by adding water molecules to the balanced equation. In step 4, we balance the hydrogens by adding hydrogen ions to the balanced equation. In step 5, we balance the charge on each side of the balanced equation by adding electrons. Remember from the previous lesson that electrons have a -1 charge. The procedure for balancing with bases is very similar to balancing with acids. The first step is to write the reactants and products. The second step is to balance all atoms with the exception of oxygen and hydrogen. The third step is to balance the oxygens by adding water molecules. The fourth step is to balance hydrogens by adding hydrogen ions. The fifth step is to balance the charge by adding electrons. Up until this point, every step is the same as when balancing acidic half reactions. In bases, there are an additional 2 steps. Step 6 involves adding hydroxide ions to both sides equal to the number of hydrogen ions present. In step 7, any hydrogen ions and hydroxide ions are combined and water is canceled out from both sides if possible. Do steps in 6 and 7 look familiar? They should. They are the same final steps for bases from balancing with oxidation numbers. More often than not, you will be asked to balance an entire redox reaction, like in the example shown here. It will be necessary to separate the components so that the half reactions can be balanced separately. Step 1 is shown here for both half reactions. Here are the 2 half reactions after they have been balanced. Notice how the reduction half reaction includes 6 electrons and the oxidation half reaction includes 2 electrons. It will be necessary to balance the number of electrons lost in one reaction to the number of electrons gained by the other reaction. We do this by multiplying the coefficients with a number. Here you can see that the bromine half reaction was multiplied by 3 prior to combining it with the dichromate half reaction. Finally, once the electrons are balanced, the 2 reactions are combined. If you do your work right, you should not see electrons in the balanced redox reaction. We will need to practice this process in class with more examples.